Hello guys, welcome to Lim Gautek's YouTube channel. Today we are going to do 5 KBAT questions about functions. So here is the first questions. Find the range of gx equals to absolute of x squared minus 2x plus 3 for the domain minus 3 less than or equals to x less than or equal to 4. Then sketch the graph. So actually there's two approach. So let's start with first approach on the left hand side here. So since you know the range of x is from -3 to 4, so you need to list out the important points, which is normally the side of range. Well, in this case is -3, 0 and 4. But then note that since you need to observe the patterns, right? So I also include the -1 and 1. So you just sub in the values of -3, -1, 0 and 1 and 4 into this function and then find out the corresponding value. Then you will roughly know the graph pattern. Since this thing is a quadratic graph, so you know it is something like a smiling face here. Okay, so you just draw it as it is, and then for range -3 to 4, you know that minimum point is at 1, which is 2, and then the maximum point is at -3, and the gx value is 18. So the range is like this. Okay, so second approach is that if you have learned this discriminant method, you find a discriminant of a quadratic function. So you know that its discriminant is -8, which is less than 0, meaning that there's no real root. So the graph will be something like this, a smiling face hanging without touching a x-axis. Okay, so you then use a differentiation to find the gradient of a function. So you know that the gradient is 2x minus 2, as if you differentiate x squared you get 2x, differentiate -2x you get -2, and then 3 you can eliminate it. Okay, so you get this, and then at the turning point the gradient is equal to 0, so you got x equals to 1 is a turning point. So that's why I include 1 in this case. So since in the first approach we don't know the turning point, right? So we'll include the possible turning point. But if you use an approach 2, you can straight substitute x equals to 1, and then you just find values for -3 and 4. So you can straight plot this graph. The continuous part of second approach is the same as the first one here. Okay, so let's move on to the second question. A function gx equals to ax minus 4 over x plus 1. Find the positive value of a for which there's only one value of x, satisfying gx equals to x. So gx equals to x, meaning this thing equals to x. Okay, so you move the x plus 1 to the right hand side and then times it up, you got this, and then you move ax minus 4 to the right hand side. So in the left hand side you only left 0, right? So you got this thing, and then you factorize out the x, so you got 1 minus a here. So it is a quadratic equation. And since there's only one value of x, right? So there's only one solution, meaning the discriminant is equal to 0. So you just sub in b squared minus 4ac. B is 1 minus a is 1, c is 4. Just sub it in, and then this one 1 minus a bracket squared. Like last video, we have did it using a plus b bracket square formula. You expand it, and you got this. And then summing it up, these two values, you got this. So now you need to factorize a, and then you see this is minus, right? So 1 is positive, 1 is minus, and then 2. It is trying out the values, so you got 3 3, and 5. So A can be 5 or -3. But then since here it says that A can only be positive, therefore the negative value is ignored, and the answer is A equals to 5. Let's move on to the third question. Fx equals to mx minus 5 over x minus 2, and its inverse function is given by this. Find the value of m and n, value of p if fp equals to 2p if m and n are integers. Okay, so you know the fx, you know the inverse function, and then note that there's both variables inside it, so you cannot find one another using given values. Therefore, you need to use this theorem where f inverse x equals to the original value x. So you just sub in the f inverse function here, and then sub this thing into a f function. So you got this equals to x, and then note that the upper the numerator and denominator share the same thing, x minus 3. So you got to move this -5 up there, move -2 up here, so that you can cancel out this x minus 3. So this is what I did. Okay, and then now you can cancel out this and this, so you only left this over this equals to x. And then when I continue here, right, I move the denominator to the right hand side, so it becomes times. So after you do some simplification, you got this. And then by comparing, since both sides are first order polynomial of x, so you can say that the coefficient equals to the coefficient. So 2m minus 5 equals to n plus 6. And then doing some simplification, you got the first equation. And then the second one, mn plus 15 equals to 0. So this is the second equation. So now you got two equations, two unknown, so simultaneous equation. So you sub first one into the second one, so you got a quadratic equation. Factorize it, you got n equals to -5 and -6. So sub it back to the first equation, you got the m value for each case. But note that the 5 over 2 is not integers, and given that m and n can only be integers, therefore we only choose n equals to -5 and m equals to 3. Okay, so let's move on to the second part. Find the value of p if fp equals to 2p. Okay, so fp equals to 2p, sub in the function p, so you got this equals to this, and then move p minus 2 to the left hand side, so you got this, and then this one you expand it, so you got this, move it to the left hand side, and then here only left 0, so you got this. Okay, so sum it up, got the quadratic equation, factorize it, and then you know the answer is p equals to 1 and 5 over 2. Okay, easy, right? So let's move on to the next question. Given fx is this, and then inverse function is this. But this is different than the previous question, as this time there's no unknown in f inverse. So we can use the f inverse to find back the fx, so that we know the h and k. Okay, so now how to find back the fx? Okay, so you let f inverse y equals to x equals to, you sub y into the inverse function, so you got this, and then you move around so that y is in terms of x. So you move this to the left, and you got this, expand it, and then move everything of y into one side. So this one you put it here, this one you put it there. Okay, so you factorize out x, put everything x into right hand side, everything y into left hand side. So you got y in terms of x. And then here, since we know that f inverse y is equals to x, so you know that fx equals to y. And then since y is this thing, so you got fx given function equals to this. So by comparing, you know that h is 4, k is -9. Okay, so the second part of a question asking us if find the x if fx equals to 4x. So fx equals to 4x, and then move this to the right. So you got this, and then like usual, you put everything to the right and then expand it. You got the quadratic equation, factorize it out. So you got x equals to 3/2. If you guys facing problem solving quadratic equations, right, I might make a video about that chapter, okay? Don't worry. So let's come to the last question. Diagram shows a mapping of y into x with a function fy equals to blah blah blah. Mapping of y into z with a function gx. Find a and b, function that map x into y, map x into z. Okay, so now you got two functions, fy, gy, and then from the map, right, you know the value of 3. If you map it to the x, you got -2. Map it to the z, you got 1. So just sub in the values. Fy equals ay plus b. So from here, if you sub in the y as 3, you got fy equals to -2. So 3a plus b equals to -2. This is the first equation. Second equation, you got gy equals to 5/3y minus b. So if you map y to z, you sub y as 3 into here. You got gy, which is z, equals to 1. So you got 1 equals to 5/3 times 3 minus b. So here you move the denominator to the left. You got this. And then b equals to 4. So you know b equals to 4, you sub it back to the equation here. You got this. Move around, you got a equals to -2. Okay. So let's move on to the second question. Find the function that map x into y. So you got the function for y to x. What is x to y? X to y is the inverse, right? So you got the fy equals to -2y plus 4. Since you got the a and b value, right? So just sub it here. Okay. Next, you want to find the inverse. So whenever you want to find the inverse, right, let f inverse y equals to x. So fx equals to y equals to -2x plus 4. So now you move everything of x to one side, everything to y another side, so that you got x in terms of y. So move around, you got x equals to 4 minus y/2. So f inverse y equals to x equals to 4 minus y/2. So f inverse x is this. So we are done. And find the function that map x into z. So that map x into z, which is x into y and y into z. So what is x into y? Is the function that we calculated in b, right? And then what is y into z? Is gy, right? So we know that this thing is f inverse x. So just do a composite function, sub it inside, then sub this inside gx. Simplify it, you got this. Thank you for watching this video, and if you all would like to see more math and engineering mathematics video in the future, do subscribe and see you all next time.